All right, this is part C video lesson for autoionization of water. And we're going to look at this last example where we're determining the hydrogen ion concentration and hydroxide ion concentration in 500 mils of aqueous solution containing 2.6 grams of dissolved sodium hydroxide. So there's a lot of information in this problem. So the very first thing we need to do is we need to write out our givens. So our first given, very easily, our mass of sodium hydroxide, 2.6 grams. And we have a volume of sodium hydroxide, and it looks like that is 500 milliliters. And we know, though, concentration is usually in mole per liter. So we have to take this volume and convert it into liters, which 0.500 liters. Now those zeros are significant, so they need to stay. Finally, the last piece of information that you have that you probably forgot you have is your molar mass. And we actually are going to need our molar mass today because we have to calculate the concentration of our sodium hydroxide. And looking at your periodic table, using your periodic table, your molar mass of sodium hydroxide is 40.00 grams per mole. So the first step for this problem is to calculate the concentration of sodium hydroxide. And the best way to do this is a factor label method. So the concentration of sodium hydroxide is going to equal our mass, and we're going to convert that mass into mole using our molar mass. We are canceling out our grams unit, and we want to keep our mole, so we put our 40 grams on the bottom and 1 mole on the top. And then we want to turn this into a concentration, and we need a mole per liter. So we just put a 1 up here, and we put our 0.500 liters down here. We do our math, and we get 0.13. And a quick unit check shows us that the grams cancels out perfectly, and we're left with mole per liter. So our unit, mole per liter, exactly what we're looking for. So we know we set this problem up correctly. So we have a concentration of sodium hydroxide. Now we have to take that concentration of sodium hydroxide and calculate our hydroxide ion concentration. And that's really easy because this is a group 1 acid, or a group 1 base, so it is a 1-to-1 ratio. So the concentration of sodium hydroxide to hydroxide ion concentration is a 1-to-1. And so when the sodium hydroxide is 0.13, hydroxide is X. Just showing you the process. I know you can do this without math, but you will have to use math for more challenging questions. So the X equals 0.13. So the hydroxide ion concentration really should probably have an AQ in there, equals 0.13 mole per liter. So the question is asking us for a hydroxide ion concentration and a hydrogen ion calculation. So your step 3 is to calculate. So we're going to calculate the hydrogen ion concentration. And you should know by now how to do that. So hit pause and calculate that. So if you've done it correctly, you can see the steps here, but you should calculate that the hydrogen ion concentration equals 7.69 times 10 to the negative 14 mole per liter. And of course, you're going to finish off with a nice therefore statement. So therefore, the hydrogen ion and hydroxide ion concentrations are 0.13 mole per liter and 7.69 times 10 to the negative. Oh, that's backwards. mole per liter respectively. But actually, I have to fix it because I have it worded incorrectly. So it should be, because I've listed the hydroxide ion concentration first, and this one should be hydrogen ion. So it makes sense here because our hydroxide ion concentration is quite a bit bigger, like significantly larger than our hydrogen ion concentration. And that makes perfect sense because we are dealing with a very strong base. Okay, so that's the video lesson for autoionization of water. I'll have some practice posted for you as well, which you will need to look at.